In this video, we're going to take an introductory look at iOS XR. Well, when it comes to iOS XR, there is a few things you just have to know. Now, iOS XR is, like I mentioned in the introductory video to this section, is specific in most cases to the service provider track. You are not likely going to see this in every environment you touch, simply for the fact that this is a higher end box designed for high forwarding capabilities and things like that, specific to the SP track. So as we progress through here, there's going to be a lot of service provider specific things that we talk about and why they're relevant to this particular track. So the first thing we're going to talk about is the classes of routers, because of the fact that there are a few different platforms that iOS XR is on, and that is it, where the majority of what most iOS engineers have played with is going to be on regular iOS, and in the newer platforms like the ISR 4K, iOS XE boxes like the 3850 to 3650, those platforms are more to the iOS XE platform and the newer version of code, where iOS XE eventually will basically wean out older iOS to where iOS XE will be the platform that Cisco moves forward with. We'll also take a look at iOS XR architecture. So it's important to understand how, from a software perspective, how the architecture is built out on the platform. How does the platform interact with the software that sits on top of it? We'll take a look at the CLI access and how it differs and is the same in some regards to regular iOS. It does take some getting used to. It's not like, if you're brand new to iOS XR that you're going to be able to pick it up right off the bat. It's not like if you're an iOS engineer and you pick up a iOS XE box like an ASR 1001, you're not going to be able to pick it up as quickly. So because of the fact that iOS XE is running as a daemon or iOS D as it is run inside of iOS XE, it is not the case with iOS XR. It's a different command structure. Things are configured differently. There's a slightly different show command setup and syntax. So we'll take a look at how that works and how you would manipulate that. We'll also take a look at the access log and login, as well as the command modes. In iOS, you have user mode, you have privilege mode, you have config T mode. It's not the case here. You go right to enable and you go config, and some other options that go into that. So we'll take a look at that as we move forward. Cli Prompt Syntax is going to be important to understand how, when you're moving forward through these different command modes and these different CLI prompts, that you know what you're doing when you're doing it. Now, like iOS and iOS XE, those two platforms have, when you hit the enter key for a command, it takes it right away. It automatically is committed to the configuration and away you go. And if you're like me, you probably have made mistakes in production or during testing and things like that, and you've broken something and you've had to flip it back right away. Where iOS XR does something a little bit differently. You have the option, what they call the commit option, where if you're familiar with the Juniper side of the house with Junos or ScreenOS, and I'm pretty sure it's specific to Junos, because I don't really know, I haven't been on Juniper in a long time, but I know on regular Junos they had the commit option, to where you could go in there and you could commit the config, and it wouldn't actually submit the configuration to the running config until you hit the commit command. So these are different options that are available in these newer platforms that need to be understood. And then we're going to understand the command mode examples and exactly how they work forward. And then as we progress through there, we're also going to take a look at the iOS XR configuration. We'll take a look at command line editing, configuration editing, take a look at virtual routing and forwarding and how that works, committing a configuration, configuration management, configuration session management, and all the good things that go into all that, because it's really important to understand all the different levels of complexity that make up iOS XR. Now, granted, it's not like a brand new platform. It's not complete, if you understand how OSPF works, if you understand how IP routing works, if you know how Hsrp works, then the protocol themselves don't change. It's how they're implemented in XR that needs to be understood. And there's a couple fundamental differences between XR and regular iOS that you need to be aware of. Once you understand those differences and you're able to correlate the two, then you should be good. I am still in the process of getting myself on the checklist of knowing exactly what I need to do, where I need to do it. because it's still a newer platform for myself. Even though I work on it every day, I still have to think before I hit the enter key. Okay, what else do I need to do here? And it's just more like, okay, before I hit the enter key, what is this going to do? I take a couple seconds, I think about it, then I go ahead and send it. Now, when it comes to the classes of Cisco routers, you have three different classes. You have iOS, iOS XE, and iOS XR. Now, within iOS, you have the functions are routing, switching, internetworking, and telecommunications. So what this means is you could use the router as a router. You can use iOS on switches. You could use it to route in between subnets, things like that. A router could also be used for voice over IP. So a very popular router platform that was popularized with Call Manager Express was the 2811. It's a lot of people that I know that study voice. That is a router that they had, and that was routing all their voice traffic. So telecommunications is definitely possible with inside of a router. You can run your entire, as far as I understand it, you can run an entire call infrastructure, voice infrastructure on top of a router. Multitasking operating system. iOS is good for a lot of things, but the one thing it was bad at is if one particular process stopped working or was working incorrectly, you could potentially crash the whole box. Now, the drawback to this is, typically speaking, it was rare that this would happen, but you could run into issues where you might have a memory leak. That was pretty common in some of the lower level platforms. Multitasking specifically means that the router has to process everything at one time. Now, this could be bad if you're dealing with a single core processor. The processor can only handle one calculation and one process at a time. It can't do 2, 3, or 4, or 5 things at once. It just is impossible to do. You've got one brain, you can only do one thing at a time. So that's one thing that is a drawback to Cisco iOS. Now, some of the systems that run iOS software, you're going to have the what they call the ISRs, or the Integrated Services Routers, the 800, 1900, 2900, 3900. These are referred to the ISRG2s. Now, you had the ISRG1s, which is the 1800, the 2800, 3800, things like that. And those are platforms that gave you that flexibility. You also have the 7200 and 7600 series router. These two platforms, the 7200 and the 7600, were popularized at the edge for like the SP environment, where even in my current SP right now, we have a 7600 deployed, and it works just fine. Those are platforms that you would see. Those are higher end platforms, typically Service Provider Edge. 7200 was more or less seen at the customer premise equipment, and the 7600 was seen inside of the SP side of that same connection. You also have the Catalyst 6500 series switch. This is just an example of some of the platforms. This is not all inclusive. Now with iOS XE, it's a little bit different. You have an improved services integration, advanced high availability, the ability to use previous Cisco iOS management skills, rapid feature delivery, and you have universal image. Now the key thing here is when you're dealing with iOS XE, you go into what they call packages. Now with older iOS, you had a single image, and this image, depending on what level of services you need, that's the image you would have to buy. So if you needed all the bells and whistles for everything, you'd have to go out and buy Advanced Enterprise Services. This is what you would have gotten tested on in the CCNA lab exam. This is what you would see where you have a lot of features that are needed for what you need to do. Now with iOS XE, they go based off of a universal image, where what they typically do is they go off of a licensing model. You would get your platform, you would install the platform, and then based off of the image that you need to run, the services you need to apply and run, then you would use a licensing model to unlock advanced features. So all of the operations and capabilities were in one image. You just be able to go in and unlock them as you would need them. Now, this isn't all-inclusive. I know not all XE specific platforms ran off of the universal image. At least in my experience, that's what it is. I don't work in pre-sales. I don't work in solution architecture, so I don't know all of the part numbers and all of the individual iOS versions off the top of my head or by heart. I just know that on some 15 code, If you're dealing with 15 code that does not specifically map to iOS XE, it didn't always map to universal. There was some other options that were available, like IP services and whatnot options available for you. Universal image is more specific to the XE platform itself. Now, when it comes to the platforms that iOS XE runs on top of, you have the ASR 1000 series, or the Aggregation Services Router. So you have ASR 1001, 1004, 1006, ASR, I think, want to say the 900, even though I've never played with that platform. I believe that's another one that falls inside of iOS XE. And then you also have the Catalyst 4500 runs off of that platform. I know newer models like the 3650, the 3850, those platforms run off of iOS XE as well. So, as a matter of fact, I just deployed a couple of 3850 switches last weekend. It went quite well. They had this handy little command to help you join two switches to the same stack. Worked out quite well. Now, the thing that's interesting about XE is when you're dealing with it, it's a kind of a unique blend of capabilities. So, like for instance, you have the ASR 1000 series. So, I don't know if you knew this or not. If you didn't, you're about to find out. But the ASR 1000 series router, if you were to look at the virtualized version of that, or the cloud-based option, is the CSR 1000V. Now, the CSR 1000V is a platform you can download from Cisco's site, deploy into a ESXi environment, and then you can run everything inside of iOS or inside of ESXi. So a lot of the content that I produced for CCIE was done on the CSR 1000V. And you can tell when I'm on GNS3 versus when I'm in CSR 1000V because of the fact that with the CSR 1000V, the interface naming structure was gig1.x, where in GNS3 it was gig1/0.x. So there was a slight change, and you could tell from there. Also, GNS3, if I was to do like a show run section BGP or something like that, the return on the syntax for the show output was a little bit slower than the CSRs were. But that's kind of gives you an idea of the options that you had there. Now, when it comes to iOS XR, this is the, I wouldn't consider it the bread and butter, but it's the platform that's specific to the service provider track. There's also another platform out there called Nexus, and if you're not familiar with that one, or NXOS for short, Nexus is using the data center track, and that is for the Nexus series of switches, like the Nexus 2K, 3K, 4K, 5K. There's a bunch of options out there for them, but those are the next generation 6500 switches that are out there that are dedicated to like 10 gigabit, 40 gigabit capabilities inside of the data center. When it comes to iOS XR, you have improved high availability. Gives you a lot of flexibility with what the option gives you. Now, a lot of the options that I'm going to be covering here are just going to be feature capabilities, but are not unfortunately going to be available inside of the iOS XR V image that we're running with inside of Viral. So a lot of the upgrading the operating system and things like that are not capable of being done, and at least in my in the research that I've done and the testing that I've done, they're not capable of being done. There's certain features if you follow this course into CCNP, there's going to be certain things that are not supported. Layer 2 VPN wise inside of like the CCNP, or if you're preferring to study for CCIE down the road like I am for service provider, there's certain capabilities that XR does not support. And the main reason for that is because those features are specific to the line card itself, and we don't have any line cards to work with. We're working off the general purpose CPU of the router and being able to manipulate certain features of that. So there will be limitations to what level of complexity we go through and how deep we can take our different implementations. But pretty much everything that I've tested out so far has been supported, because we're not getting into the really corner case setups with, inter-AS L2 VPNs that like you could potentially see inside of the later exams like CCNP and CCIE. So those advanced configuration options from the research that I've done and the testing that I've done are not supported, at least completely. There is some level of support, like where the control plane will work, but the data plane won't. So you could propagate MAC addresses, but you won't actually be able to ping across, because ping is typically going to be done in the data plane. Better scalability. So you have the ability of adding things very, very quickly to iOS XR. It does give you the feature flexibility in that regard. Package-based software distribution. You have the ability to install upgrades and patches, and it's got a web-based GUI for system management. We're not going to touch that. It's actually not available inside of iOS XR. I will run through how this stuff works with the software distribution and the installing upgrades and what they call the SMUs and things like that as we go forward, because the upgrade process is different than what you would normally use for iOS XE and iOS. So we'll be doing a lot of pulling up the product-specific pages for iOS XR when it comes to those things, and I will point you to resources that'll help you out with that. Unfortunately, I don't have access to XR boxes that I can do that with. We're going to be limited to the capabilities inside of whatever viral options we have inside of those XR boxes and whatever XR platforms I have that are running as virtual machines from Cisco's website. So what are the different options that we have for platform-wise? Well, you really only have three. You have the CRS 1 and 3, you have the XR 12,000, and you have the, that might be the GSR platform. I've never actually touched that one. And then we have the ASR 9K. Not to be confused with the Nexus 9K that is typically referred to in the ACI world for the software-defined networking, where in the CRS1 and CRS3, those stand for Carrier Routing System. Those are going to be similar in fashion to like your Nexus 7009, I believe, and the 6500 Catalyst, where they are line card based routers, where you have like actually I'll just draw it out, make it easier for all of us to understand how this would work. Actually, I'll pull up a picture of a couple CRSs and you'll see what they look like. So in the picture on your screen, you see a picture of a CRS1. This is an 8-slot chassis. And what this basically means is these guys right here in the middle are going to be your supervisor modules. And these other guys here that I'm drawing lines on, these are your line cards. And what you would normally do is you'd slide in the line card. This could be like a 10 gigabit connection. This could be a 40 gigabit or what have you. It just depends on what you're trying to do with the platform. So this is what a CRS would look like, and it actually says CRS right there. Now this is a CRS. This is an 8-slot chassis, where you could get, if you look above the screen here, you get into these platforms right here. These guys up here are typically, you'd have like the 9916, and you have like the 9016, and then you have the 9922. And typically when you're getting into the 9922, you're looking at 1.8 terabits per second. This also is referred to as Megatron, because this router is actually a full rack height. That's how big the router is. And I'm willing to go out on a limb here and state that if you're dealing with one of these routers, it's very possible, not a guarantee, but very possible, that this router right here, you might actually be transiting your traffic through there from, if you're watching this video, you might actually be transiting through a CRS router to get to where you're at. So that's going to be one of the interesting things about these platforms that are, and that's one, when I talk about 1.8 terabits per second, that is chassis total, not line card port level. That is not line card specific. That's chassis total backplane forwarding capability. So it's a very, very fast platform, very, very scalable. So now when I talk about the XR architecture, it's important to understand exactly how that works. You have the microkernel for basic operation is the QNX, where the multi-process for each feature or function is a separate process. So if something was to die or check out and not want to work anymore, like say for instance OSPF or BGP, it's not going to crash the whole box. You have logical separation of management and control and data planes, supports high availability, fault tolerance and isolation, and supports Cisco's iOS ISSU, where ISSU stands for in-service software upgrade. So what that means for you and I is those dual line cards we just described, those are going to be able to be run at the same time, where one would run as active, one would be in standby, where you'd actually be able to upgrade the standby line card and then fail over to the new operating system and then upgrade the other one so that your router never has to go down. So you never actually have an outage window. When it comes to process restart, this is generally how it looks when you take a look at monolithic iOS, where the green areas you cannot restart. So anything that crashes could potentially take down the whole box. Now, in my early days of IT, there were a handful of times when I was working on customer equipment and we were trying to troubleshoot what the problem was. I actually did a debug IPNAT detail, and that actually spiked the CPU at 100%. It locked me out of my SSH connection to the router, and then at that same point in time, the customer called about a minute later and said their internet was down. So it actually crashed the box because there was just too much going on, and the router could no longer forward. Now, what's cool about XR is you have the ability to go in here and restart different services. So you can go in there and restart RIP, you can restart OSPF, you can start VPN, things like that. And the only thing that cannot restart is the timers in the scheduler, because you can't restart something that, like, the timers are being dictated by the scheduler in some cases and vice versa. So it's one of those things where if you have the flexibility of going in here and manipulating things, you can do that, but you've just got to be careful of what you're restarting and when you're restarting it. Now, the CLI is actually pretty straightforward. You can console to the RP and standby RP, or the inactive RP. The RP stands for route processor. So you have the auxiliary console to RP. So you have an auxiliary console, so you have basically the ability to hook up a modem to it and connect into it that way. You have IP management to active RP on both management interfaces, so you can set up high availability. Now, the way this works out is it's similar to the way that, if you're familiar with the routing and switching track, you might have heard the term Hsrp. Now, what this means is, or VRRP. Now, with Hsrp, you would have to give, if two devices are going to be running Hsrp, they're going to each share a virtual IP address. Whatever router is actually as the dedicated forwarder, that would be the IP address that you would be forwarding traffic through. VRRP allowed you to utilize the interface IP address as the virtual IP. That's why I brought it up the way that I did, because you could have the virtual address like that. We will not be able to demonstrate this because we only have one CPU to play with. But this is an output and an example of what you could see on a real XR box if you happen to work on them or have access to one. And this is not mappable to like the ASR 9001, which is just one CPU. So the interesting thing about this is management Ethernet 0. In my research and my practice on XR, I have not. This platform doesn't actually support the capability to do that. So it really depends on the situation you're walking into. Although I haven't had very positive results when I play with specific things like that. But then again, on the XR platforms that I've been working on with inside of Viral and the VMs, we only have one CPU. So it doesn't make a difference to have redundancy at the management level either. Now, logging access and login. When you log into the XR router, you can console directly to the console port. You can use a terminal server connected to the console port, or you can use Telnet or SSH to connect to the box. It's up to you and how you want to do it. Most of the ways are pretty straightforward. And then you have a login, root system user defined at initial installation, and assigned username and password. When you are inside of Viral, you don't get a root system user initial configuration. You are told what username and password you can log in with, which is going to be Cisco for username and password. If you use the virtual machine, you are prompted for that. And that's the only thing that's unique about the initial configuration is you have to provide a username and password. The command modes are pretty straightforward as well. You have exec mode, you have configuration mode, and sub mode. And then you have the admin exec mode, and you have the admin configuration mode and sub mode. So what does this mean? So you have exec mode, which is going to be similar to privilege mode 15 inside of regular iOS. So it's got the host name with the pound sitting at the very end of the host name, and that's what you use all your show commands for. Configuration is where you're actually going to go to global config. You're going to be in configuration mode, and if you go underneath the router static, router OSPF, show IP interface brief, interface configuration mode, those are going to be considered sub modes and going to be specific to that. You also have the admin mode. You have admin exec and admin configuration and sub mode. Admin mode is going to be where you're going to be doing things specific to the router itself for management. Configuration register setting, so how am I going to boot the router, how am I going to boot the operating system. You can manage and configure secure domain routers, which an SDR, if you're not familiar with them, is a way for you to basically take a XR box that has the ability to support SDRs and take and carve up the router into different logical routers. So similar in the way that Nexus has VDC or virtual device context, this is similar in the same fashion of multi-context mode inside of ASA. So you can have multiple contexts and then give each one of your customers a different context if you're inside of what they refer to as a multi-tenant environment. This is where you would configure the root user setup and install your software. When it comes to Cli Prompt Syntax, it's important to understand exactly how this works. So on the ASR 9000, this is going to be the output we're going to be seeing. We're going to have the route processor, and this is going to be the output. So you have the RP as the route processor card. 0 is always the same. You have route processor, either RSP0 or RSP1. Then you have CPU 0. It's always the same. And then you have the router is going to be the router host name. So when you go in here and you go to global config and you type in hostname XR1 or hostname XR2 or hostname, INE1 or whatever the case may be, whatever you want to configure as a hostname, this piece right here, this router, will change to that. Everything between the colon and the pound will become the hostname. Now, some of the command modes that are out there that are for XR are you have the exec process, which is what this is going to be. You have config mode, which is where you would type in configure and hit the enter key, and then that's what you're going to get. You have sub mode, which if I wanted to go and configure the packet over sonnet 0200 interface, I would type in that command and then it would take me interface config interface mode. If I wanted to do a sub mode beyond that for routing, I would type in router BGP 140, type in the address family that I want to configure under BGP, and then I'd be under AF BGP mode. I also have admin and admin sub mode. So it gives you a lot of flexibility in that regard. So just think of the first four here, the top four here, are how you would configure forwarding of traffic and things like that. Where the bottom two are going to be for administrative access, setting up your upgrading the operating system, work specifically on the router itself. Now iOS XR configuration is pretty straightforward. The way this works out here is pretty simple. So I like the little flowchart that I was able to find. It actually helps dial in some things for you right away. So when you first log in, you immediately go to exec mode. From here, you can jump into admin exec. So you would type in admin and you would go to this level. Now you can go exit. If you do that, then you can go ahead and you go back to exec. Exec is where you're going to want to sit for the majority of your time. Now if I'm in admin mode and I want to go in here and say I want to configure a new root system user or I want to upgrade the software, I would type in configure and that would drop me off in admin configuration. I would do what I got to do here. I would commit the syntax and then I could do a do show run and that's going to show me the output for the admin configuration. Once I'm done, I would hit exit out of that, I would be back in admin exec. Press exit again or type in exit again, I'm at exec mode. Now that I've done my upgrades or I've added my users or whatever the case might be, I could then say, okay, well now I need to configure OSPF. So I would type in configure and I'd be in global config mode. I'd be able to do whatever I need to do there. From here, I could type in commit, save the configuration to the running apply it to the startup config as well as the running config. Now the thing about this is, for those of you that are familiar with iOS, the write command and the copy run start are a thing of the past. If you say copy run start, you have now just saved a absolutely useless file inside of the flash. Same thing with write. These commands have no bearing and they don't do anything anymore. If you're in iOS, you obviously know what these guys do. They save your running config to the startup config. So if there's a reboot, your config will come back to you. Where in regular XR, or inside of XR configuration, the commit option is what you do to save your configuration. You commit that to the running config, and it automatically saves that in the startup config. Now, configuration editing, you have a couple options here. Commands to clear the configuration. You would go to global config and you would type in commit replace. I usually append the end of this with a force, so it does not give me any issues whatsoever. If there is no startup config, you can do a write erase, there is no startup config. So the idea here is, if you want to replace the configuration, so the way this would work out here is this, and I'm about to show you this here in the next portion of this video. So the way this would work is, if you have a running config, an already in place configuration on the router, you would come in here and type in commit, and you wanted to blow it away and start over with a brand new, which is what I'm going to do with you guys here in just a moment. You're going to do a commit replace force. That's going to trigger the router to replace the configuration with the way that it comes from out of the box. Okay. Then what you're going to do is you're going to jump out of global config back into privilege mode, and you're going to do what they call the clear config commits, and you're going to say oldest. And then what you're going to do then at that point is it's going to give you, when you hit oldest and you do a question mark, the oldest it's going to start out with the lowest number, which is 1, through, say, you've got 30 commits, you made 30 different changes to the router. You're going to say 30. What that's going to do is it's going to erase the any of the config changes you've made previously to that, and then you're going to be done. That's going to be the end of it right there. And then you've got nothing saved in that you can roll back to. That's one of the things that's nice about XR, is you can do a show configuration commits, and you can actually see what was done on every commit you did. So if you wanted to roll back to a certain point in time, you would just have to do a rollback command, and it would roll back the configuration to that point in time. Very, very cool stuff. Now, when it comes to virtual routing and forwarding, if you've never heard of this, that's okay. It's a pretty straightforward technology and configuration capability. But basically what you're doing is you're segregating the traffic. The idea here is, if you're familiar with what a switch does, and you should be since we just covered it. So we talked about how switches use VLANs to basically take a switch and create different broadcast domains and carve up the different ports into different layer 2 networks. Well, the VRF, or virtual routing and forwarding table, also referred to as a VRF, it does the exact same thing but on a router. So a router allows you to create virtual routing and forwarding instances, and then once the instance is created, which is going to be basically is the broadcast domain, which is the VLAN, which is also the MAC address table and things like that, you're creating a VRF, and then you can place interfaces inside of that VRF, which gives you the flexibility of going in and getting things configured as you need them. So it allows, with the VRF definition capability, allows for forwarding of IPv4 and IPv6 traffic. The reason why we're going to use the VRF definition instead of just the VRF itself, or VRF forwarding, is VRF alone just does IPv4 forwarding. We're going to be focusing on IPv4 and IPv6 throughout this series, and CCNP and eventually CCIE. So it's important that we utilize something that's going to support both protocols from the start. So we know that as soon as we get started with this setup here, it's immediately going to be using both v4 and v6 traffic forwarding. So it only makes sense to implement options that support both capabilities. Now, committing a configuration is actually really simple. You would do a show config. You could, when you are in global config and you want to see what you're about to commit, you can do a show config, and that's going to show uncommitted configuration. You can do show config merge, which is show future running configuration after a commit, what it will look like. And show config changes, show future running configuration after a commit replace. So you can see exactly what's going to be happening as you move forward. Now, committing, you have these options in front of you. Commit best effort, commit whatever you can, not all or nothing. Now, if there's an issue, you can go in here and the parser is going to squawk at you and say, okay, there's a problem. You can't do this, you can't do that. So there's definitely some flexibility in here. So obviously some different options for you. Actually, let me roll back to the VRF real quick. The one thing about VRF, we're going to take a look at that on iOS XR, but we're going to also take a look at it in iOS. So if you see a duplicate slide when we talk about iOS VRF, that's okay. It's the same slide, but same flexibility as we move forward. So just in case you're aware, we're going to talk about VRFs on both iOS XR and iOS. Now, configuration management, every configuration change is stored in history. And you can do a show configuration history or show configuration commit list, and that is going to be how you would go in there and see what's been done. So that is going to be how you would go about getting that situated.